Okay, so this is an end order reaction. So let's say the rate of our reaction is Ka to the n, which equals 1 minus A d concentration of A over dt. Now for simplicity, I'm going to call A equals, define that as Y, and we already know that from previous examples this equals Ka. So again, this becomes the same basic steps. Minus Ka Yn equals dy over dt. Now this becomes, you bring this equation, you bring it over here, and you bring the dt over there. Separate the differential equation. Dt equals y minus n dy. Now I can integrate this from 0 to t, and this will give me minus Ka t equals y minus n plus 1 over minus n plus 1, 0 to t. Now this becomes minus Kat equals yt minus n plus 1 minus yo minus n plus 1 over 1 minus n. Alright, so what I could do now is this. This is just basic algebra. I could multiply everything by 1 minus n times yo n minus 1. So I multiply both sides of the equation by this. So 1 minus n minus yo 1 minus n equals 1 minus n. By doing this, I could cancel out some terms. I'm multiplying this on both sides. So what I'm doing now is this cancel this out, and this will give you 1, because 1 minus 1 is 0, negative 1 plus n is 0, so yo to the 0 will give you 1. So this becomes, this minus this changes with 1, so minus times 1 will give you minus 1, minus times minus would be positive, so it becomes n minus 1 yo n minus 1 Ka t equals yt 1 minus n yo n minus 1 minus 1. So let's see the whole equation. That's the whole equation, but we are not done. What I'm going to do is I'm going to move this to this side. I'm going to move the 1 to this side. This will give me 1 plus n minus 1 yo n minus 1 Kat equals yt 1 minus n yo n minus 1. Now what I'm going to do is this. This is basic algebra. I'm going to multiply this by basically 1. 1 minus n over yo 1 minus n. By doing this, these two terms would give you 1, would give you yo to the 0, which will give you 1. This and this, I'm going to combine them. So this is going to become yt over yo 1 minus n equals n minus 1 yo n minus 1 kat plus 1. So putting back the variables, I would have concentration A at T raised to 1 minus n over, well, we could raise this. We put it at the end. Concentration A or 1 minus n equals 1 plus n minus 1 concentration A or n minus 1 KAT. Perfect. Now for half-life method, let's find the half-life. So let's go new paper. Now the half-life for the nth order. So back to the, let's rewrite the equation. I like using different pens. All I'm doing is writing out the equations. That's all I'm doing. Now let's say that C equals C half. We know again that this equals 1/2. Again, it doesn't have to be 1/2. Oh, this could just be the fraction of the unreacted. The fraction of the unreacted compound A from the original AO. We'll talk about that later. So let's plug this in. Let's plug in this values into here. So we would have 1/2 1 minus n equals 1 minus n minus 1 a or n minus 1 KAT half. I want to isolate this. That's my goal, is to solve for that. So what I'm going to do is I'm going to, is this minus? Yes, it's minus. So what I could do is, alright, cool. What I could do is this. I'm going to move this to the side and then change this minus, make this 1 minus n rather than n minus 1. So then this will become plus. So basically I'm saying make this plus and then make this 1 minus n. That's so to cancel this out, which is the same thing. So I'm basically saying. So what I'm doing now is I'm going to move this one to this side, and so I'm going to have A O KAT half equals 1/2 1 minus n minus 1. Yes. Now I'm going to divide all of this on this side and bring it here. So first I could still reduce this. This can become 2 minus 1 minus n minus 1. This would then give you 2 n minus 1 minus 1. So I'm going to divide this and this under this. So this will give you, so I could isolate this, T half equals 2n minus 1 over a n minus 1 k a, and that's the half-life for the 4nth order. If n equals 1, let's go back to this. If n equals 1, then this whole thing would be 0. Then this raised to 0 would be 1. N equals 1, this would give you 0. This whole thing would be 0 if n equals 1. This whole thing is 0. This whole thing is 0. 0 equals 1 is not true, so n cannot equal 1. Why? Because if n equals 1, this would be 1 minus 1 is 0. Anything raised to the 0 is what? Is 1. Now, if n equals 1, anything raised to the 0 is 1. 1 plus, if n equals 1, we get 0. 1 does equal 1, but then basically we have cancelled out all our reaction. We have no molecules and no compounds, so n does not equal 1 for this reaction. What else? Well, let's see, we have the half-life for that, so that would be it.